Hey everybody, we're going to continue on here with section 8.1, sequence and series. Today this is a little bit smaller, not as much material, it might take us about the same amount of time, but not as much material, dealing with what's called a factorial notation. Okay, it's red, and you see it right here with N, and it's an exclamation point, but it's not telling you to scream N, it's just N factorial is how you read it, so that's what this is, it's how you read that. Okay, well, what is it? Well, basically what you do is you start with 1 and you multiply by the next number in the series, then times 2, times 3, times 4, times all the way up to, and I'm going to write this and it'll make more sense in a little bit, n minus 1 times n. In other words, you start with 1 and work your way all the way up to whatever that n is. Okay? So for example, I'm going to go to the bottom of this list to explain. So 5 factorial here. 1 times 2 times 3 times 4 times 5. Okay. Now, we can multiply that out. Let's see. So 5 times 4 is 20, times 3 is 60, times 2, that's 120. Okay. Bad. 120. Now, there is on the calculator, just for your future, if you have one of these calculators. If not, even the ones on computers and stuff, if you're in scientific mode, I'm pretty sure there's an exclamation point or a factorial. Here it's a little more button pushes. You have to go to math, and then you have to get over to PRB, your probability, because factorials deal with statistics and probability mostly. Okay, but they come up here because there's a connection, and then we introduce it, and you can see it number 4 there. Okay, I should have put something in here first. Let's say we wanted 5 factorial. We would go 5, and then we go math, and then we can go down to this, or we could just hit 4, and then we get an answer. And then you can see it's 120. Okay, so we can use the factorial button where you can multiply it out. Why is that? Well, what is a factorial? A little bit, it is helpful that I mention this so that we can explain something else here. So what a factorial really is it's the number of ways n objects can be arranged. So for example, if I wanted to know 3 objects, how many different ways can I arrange 3 objects? Well, let's just, for purposes, say we had the objects A, B, and C. Okay, just letters. And how many different ways can I arrange those objects? Well, I could say A, B, C. I could say A, C, B. Right? Okay. I could say, let's see, we could put B first. B, A, C. B, C, A. Okay. I could put C first, and then we would have A, B. Or we could say C and then B, A. Okay, and you'll notice there's 6 different ways. So when I ask an n factorial or 3 factorial, I'm asking how many different ways can I arrange 3 objects? And the answer you can see is 6. Well, if we use the math of 3 or 1 times 2 times 3, you can see you get 6 as well. Okay, so that's what a factorial is doing. It's about arranging objects, and this is how we do it. And we use that to find answers. So then 4 factorial will be 1 times 2 times 3 times 4, which is 24. 2 factorial, 1 times 2, and that's 2. 1 factorial seems strange. We just have 1. Okay, now here's the crazy one. It's 0 factorial. Okay, how do we do that? At first glance, you'd be like, you can't. All right, well, we can. The answer is going to be 1. Okay, by definition. So if you don't like that, just remember that 0 factorial is 1. It's important that we have that kind of place. It's like a placeholder in a sense. It's kind of similar to powers, and something to the 0 power is 1. If we didn't have that, we couldn't do a lot of things. All right, but let's explain it in terms of this definition. Remember, what I'm asking is, what's the number of ways that I can take n objects and arrange them? So over here we said 3 objects. Well, how many different ways can I arrange 0 objects? 1. I still have 0 objects. So that's why we say 1, because I can arrange 0 things in 1 way. I still have 0. Okay? So I know that seems strange, but that's why that's a 1. All right? Okay, so let's just kind of work with it and kind of put it into what we talked about here. One of the first things we do, kind of an order of operations, you need to understand what's the difference between those two things. So let's kind of look at that. If I was the first, I did this, that means 1, oops, not point, times 2 times 3 times dot 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 dot, and then it would be 2n minus 1 and then just 2n, because we would go one less. All right, now whereas this 2n factorial is 2 times n factorial, so that would be 1 times 2 times 3 dot 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 n minus 1 times n. Okay. All right. Pretty important that you understand this idea of n factorial as, 1 times 2 times 3 up to n minus 1. And, if I wanted to go, it would be n minus 2. Okay. We're not going to get too crazy with that, but a little bit. All right. Next, when we look at this problem here, what we're going to do is just using what we already did and plugging in. Now, we're going to write the first 5 terms of this. Remember what we do. That means we plug in. Now, normally we plug in 1 to 5, but notice I put a little note over here. Start with a sub 0. Okay, so that means I'm going to plug in 0. We do that often. 0, if you're in physics, you know that v sub 0 is the initial velocity. So a lot of times we use that same kind of terminology here with our terms. A sub 0 is the initial term. So we start with 0, and especially we do that with factorial stuff. So I'm just going to plug in. All right, and we get 2 to the 0 plus 1 over 0 factorial. Well, what's that? So 2 to 0 is 1 plus 1 over 1. So that's going to be 2 over 1, or just 2. All right, and then you plug in 1. You're going to get 2 to the 1 plus 1 over 1 factorial. Well, 1 factorial is 1. This is, of course, 2 plus 1. So that's 3. Next, second term. 2 to the second plus 1 over 2 factorial. What do we get there? So on the bottom, we're going to get 2. And on the top, we're going to get 2 squared plus 1, or 4 plus 1. So we get 5 over 2, or you could do it as 2.5. All right, so then third term is 2 to the third plus 1 all over, 3 factorial. 3 factorial is 6. And this would give me 8 plus 1. So that's 9/6, or which you'd reduce it to 3 over 2, or 1.5. Okay. And finally, the fourth term. I said the first 5 terms starting at 0. So that's 2 to the 4th plus 1 over 4 factorial. 4 factorial is 24. 2 to the 4th is 16 plus 1. So we get 17 over 24. You could leave it like that, or I believe the decimal is 0.70833. Okay. So that's the idea there of just kind of plugging in, using some factorials. There's going to be a few of those. All right, it's kind of combining what we've done in previous with this one as well. All right, so then the last thing we're going to look at is just kind of simplifying with factorials. This is kind of important. To be honest, these ones here, you could just plug in the calculator as is. Okay, this one you can't. All right, so we could just plug that in and get the answer, or we can kind of think things through a little bit. Let me show you the first one here, and let's write it out. 1 times 2 times 3 times 4 times 5 times 6 all over 1 times 2, and then times 1 times 2 times 3 times 4. The reason I do that is we can cancel things out. So I would cancel the larger terms, and that would be this with this, right? And so then what do we get on top? Well, 5 times 6 is 30, and 1 times 2 is 2, so my answer should be 15. Again, if you type that in all in one shot, you should get 15. Just be careful on the bottom here. When you type that in, you should put parentheses around that. Okay? I'm going to show you a slightly different way to kind of think it through a little bit. Let's see if this makes sense. So 6 factorial, and the reason I would do this is because I know in my head I can, 4 factorial is less, so it's going to kind of cancel there. I could write 6 factorial as this, 4 factorial times 5 times 6. And on the bottom, I could leave this as 2 factorial and leave it as 4 factorial. So what I'm doing is I'm kind of understanding that I know this stuff here is going to cancel. So the 4 factorial and the 4 factorial cancel. I get 30, and 2 factorial is 2 again, and I still get 15. So it's another way to kind of group things. Okay? Why don't you try that with number 2? Maybe you want to pause a minute and try that out. All right. I'm going to try it kind of more of the second method. If I do that, I'm going to leave this as 2 factorial, but this top one, what would I write 8 as? Well, maybe 6 factorial times 7 times 8. The bottom I'd write as 2 factorial times 3, and I would leave the 6 factorial as is. Cancel, 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 cancel. And let's see, I get 7 times 8 is 56 over 3. And that doesn't reduce. You could, divide it on a calculator if you want and get a decimal of 18.7, or just leave it as that. All right. Okay. All right. So the reason I kind of show you, this method here and this one here is because we kind of need it that way with this. Why? Well, you got to think about what does it mean for an n. You're going to start at 1, right? 2, 3. You're going to keep going up until you get to n. Well, right before n, you're going to get to n minus 1, and the one previous to that is n minus 2. So n minus 2 times n minus 1, and then times n. And, we got to think about what does n minus 1 factorial on the bottom mean? Well, 1 times 2 times 3, and, what would we have? We'd have n minus 2, and then n minus 1 would be my last term. The reason I show you that is what's going to cancel in this case? Well, all of this stuff does, and you just get n. Okay? So you got to realize, kind of go in this direction, if n is my largest number, the one previous is going to be n minus 1, then n minus 2. If this would have been, let's say if I had something with a 2n parenthesis factorial, it's 1 times 2 times 3, bump, bump, bump. What do I end with? 2n. Well, what's the one previous? 2n minus 1. What's the one previous to that? 2n minus 2. Okay, so we'll use that, practice a few of those, and I would say that's probably a little bit of the trickier part is the dealing with the n. All right, there will be an assignment with this section as well, not a huge one, kind of a minor one with this. I do kind of break it up just because they're all kind of a little different. All right, thank you. Take care.